Okay, welcome back. So right now we're going to be going over some of the explanations for how the Egyptians made some of those achievements we identified in the last observation slideshow. So without further ado, let's jump into that. Okay, so similar slideshow as last time. We're just going to I did add a bit so you can see kind of what's going on here. Okay, so as a reminder, one of the questions was, how did they get the stones? Where did these stones come from? So we had, the different images of the large stones, and then I had this mystery picture at the end. And there's one more image of the large stones, but I had this mystery picture at the end of this area near the pyramids with these sort of square-shaped, I don't know, looks like indentations in the ground. Now, what this actually is, this is a stone quarry. It's where they took there's the bedrock in this area. The rock underneath all the sand is made of the same stone that the pyramids are made out of. And most of the stone that they took from it, they took directly from this spot where they basically carved it out of the ground. Now, as you can imagine, this does take some somewhat specialized tools. Not super advanced tools. We have very good tools that we use today, but it does take some doing. And the main tools that they would use were chisels and mallets. So this would be an example of this chisel would be made out of bronze that they would use for that. This would be a different sort of chisel. So the top chisel here would be sort of for splitting the rock apart, and then the bottom chisel would be for shaping it, getting it into the correct shape that you wanted. So, and then this would be an example of just a large, hunk of wood that they'd use to bang on these chisels to shape this wood. Now I want to show you an example of of just a modern day piece of stone being split with chisels. So this method is still used. Now we do have ways of slightly better chisels that split the rock a little bit more predictably. But this is basically what happens here. So you drill all these, we also have drills to get the chisels in, but you put the chisels in and then you hit it with a hammer or a mallet. And as you hit these chisels, it drives them down deeper into the rock, and it splits the rock apart. Now, if you've made a little groove along here, basically that then becomes the weak point, and that is where the rock will split. So you take advantage of the fact that you have both a chisel and sort of a pre-designed weak point to kind of try and get the rock to split the way you want it. And that doesn't always work, but it tends to be pretty good. So they would have had to have had these metal chisels, mallets, and some knowledge of stoneworking or masonry, as we call it. So it's one thing. The next thing is, how would they make a square? Now, the standard answer you'll get a lot of the time is, well, all you need to do to make a square is we had the two top views that shows the pyramids are perfect squares, at least their bases. I said perfect squares last time. I meant square bases. They're a three-dimensional shape, which can't be a square. The faces would be triangles, but the bases are certainly squares. So just as a reminder, the difference between a square and a rhombus. Now, the standard answer is that in order to get a square, you just need to have all the sides the same length. But a rhombus is a similar parallelogram, or is a similar shape where all the sides are the same length, but it's not a square. For a square, you also need right angles. And so this is an important thing to be able to do. Getting all the sides the same length would not be that difficult. They could, have a line of cord or rope and just, use the same rope when they're doing the surveying to make sure the sides are the same length. What's not as easy to do is make sure that they meet at a right angle, and that's what you need in order to get a square. So how would they do this? You might have access to a protractor and you just like, you measure a perfect square. Well, they wouldn't. How would you get a right angle if you didn't have access to that? And And one of the there are a number of ways that it's possible to get a right angle without measuring with a protractor. But one of the most common ways is a very simple way is by what's using by using what is called a magic triangle. It's not actually magic. It's just a triangle with a particular ratio. So what I've drawn here is 1 unit, and then if we take 3 lines, and basically you can kind of tell just from the size comparison that the red line is 3 units, the blue line is 4 units, and the purple line is 5 units. Now, what's kind of cool is if we make a triangle out of lines these lengths, it ends up being a right triangle. And then we have, and I'll show you that. So basically, just took those lines, made them into a triangle, and we have a perfect right angle here. So all you need to do is you need to have a standard unit of measure, and then you need one side of the triangle that's 3 times that unit of measure. So 3, one side that's 4 times that unit of measure, and one side that's 5 times the unit of measure. And when you make that triangle will automatically make a right angle. Now, if you combine this, if you use one of these magic triangles at the corner of the pyramid, you can make sure that that pyramid gets you a right angle there. So that is how you could use a triangle, just 3 simple length measurements to generate a right angle. There are a couple of other ways, but that's the main sort of clever way of doing it. Now, the next thing to talk about is how to measure vertical. Now, it's important to know what vertical means. It turns out this is actually not that bad. What you can do, we need to measure vertical to make sure these stone pillars were perfectly vertical before we set them up, because we don't want to be setting lintels on things that are not perfectly vertical. So this is a very simple tool. Now this is modified. The metal piece, this is actually a Roman piece, but also the ancient world. So the metal piece, this is called the bob. And basically what you do is you attach the bob, which is just a weight. You attach that to a rope or a cord, so it hangs down vertically. And then what you know from that point on is that the string or the cord makes a vertical line. Now, and the reason is gravity acts in the vertical direction. So if that cord is vertical, you can use this to test vertical lines. Now, you wouldn't be able to use it right up against the pillar itself. You'd probably have to extend it out a ways and then just measure the distance from the line to the pillar and make sure it was constant. That way the pillar is vertical. Now, this tool, we call it a plumb bob. Whoops. This is called a plumb bob. That thing. The reason it's the name plumb to measure vertical, we've already discussed that. But where this term plumb comes from, it actually comes from what the Romans used to make these things out of. They used to make them out of lead, and the Latin Roman language term for lead is plumbum. Incidentally, their pipes were also made of lead, and that's where the term plumbing comes from as well. So that this Roman word plumbum is where we get both the term for plumb bob and the term for plumbing. So a little bit of trivia there. Whoops. All right. Now, measuring horizontal is a little bit trickier. Okay. Now, one thing you can do, and it is probably done sometimes, is what you can do is if you have vertical using your plumb bob, you can get your 3, 4, 5 triangle, which is a 90-degree angle, and use that to measure a right angle. And then that something that's at a right angle to a vertical will be by definition horizontal. That is a way to do it. And that's not a bad way to do it if you have a relatively small space. Unfortunately, the entire base of the pyramids also needed to be basically level. And the base, the foundation of the pyramids is rather level. And it turns out that there's not widespread agreement as to how this was done. Now, one of the ways that I think is the most plausible is actually, and the reason I think this is plausible is we actually use similar tools today to measure level, is to use water. Now we know that when water is not bouncing around, it naturally makes a perfectly level surface. It actually naturally makes something that's perpendicular to gravity. So the argument, this is a drawing not of the Egyptian pyramids, but from I believe a Mesoamerican pyramid of how they think it was constructed. So basically, but I think it illustrates fairly well what kind of went on. Basically, what they did is they cleared the sand away until they got down to bedrock, and that would be this area around here. Now, there's no guarantee that would be flat, so they need to make that flat. Now, basically, how you would do this, the argument I've heard about how this was done, is that they would cover the entire thing with water, and then they would go along and any parts of the bedrock that were sticking out above the water, they'd grind that down until it was at the water level. And then they'd lower the water level. And then any parts that were sticking up above at that point, they'd go around and they'd grind those down as well. And eventually, once they lowered the water and then nothing was sticking out, nothing was below the water and nothing was above the water, then the ground would be perfectly level, and then you can start building the pyramid from that. So that's the idea of how you would get it to be perfectly level. So you use water to take advantage of that. If you have a level in your house, you can actually see that the levels we use today to measure level, they use water in not an identical fashion, but they do use water to tell you whether or not something is level. So check that out if you are interested in doing that. Okay, so that is it for this lesson. There are the image credits if you want to see those. So thank you for tuning in, and I will see you next time.